Today we're going to talk about more vocabulary than anything, but relations and functions. So ordered pairs can be used to show inputs and outputs. We know our ordered pairs are our x and our y's, where the x is the input and the y's would be the outputs. So a relation, first vocabulary word, is a set of ordered pairs. That relates an input to an output. So basically, anytime you have things that have an input compared to an output. So you could see it as a table where the left column are the x's, the right column are the y's, and they make ordered pairs. You could see it on a graph because all the points on our graphs are x, comma, y ordered pairs. So a relation is basically anything that you can see ordered pairs with x's and y's. So let's talk about this next thing called mapping diagrams. So a mapping diagram is just kind of a way to talk about how you compare or put together inputs with outputs. So just looking at the mapping diagram, you have these two ovals. It kind of looks like a table, but obviously they're not connected in a table form. But basically what happens is you would put your inputs, which are your x's, straight down in numerical order. The outputs are also in numerical order. They could be ascending in this case, like going up. They could be going down, like over here in this case, they're kind of going down. Okay? Either way. So then these arrows are basically telling us that the 1 is the input, and then the output comes out as a 3. That the 2 is an input, the arrow tells us the 6 comes out. So the first one is kind of almost in a normal table form. So the question says to give our input. So 1 goes in, the arrow tells us 3 comes out. 2 goes in, 6 comes out. 3 goes in, 9 comes out. And 4 goes in, and 12 comes out. So those are the ordered pairs from the diagram. The second one over here is talking a little bit differently. It still has the same idea, but notice the arrow. So in this case, the 0 goes in, and notice that it doesn't go straight across, it follows down. So notice the 0, when it comes down, goes to 0. Then 2 is an input, and if you follow the arrow, there's actually 2 arrows. The first one would go up to 1. There's another 2 that goes down to negative 2. And then 4 goes to the negative 3. So just notice that there's not a normal table in this case because you're following the arrows. So key vocabulary. So a relation. So something that we would refer to as a relation, that each input has exactly one output. And it's very important that we understand that in a moment. This is called a function. So what does that mean? So each input, which are our x values, has exactly one output, or y. So let's just look at what that means. So table A here, or the mapping diagram for A. Determine whether the relation is a function. So first, let's just make sure. The definition of relation, inputs compared with outputs. So this is definitely a relation. This one is definitely a relation. So we already know that they're relations because I can create ordered pairs. But in this case, now we want to know, is it a function? So the way you would determine that, each input, these are all my inputs, can only come out as one output. So negative 9 only comes out as a 0. Negative 2 only comes out as a 5. 5 only comes out as a 10. 12 only comes out as a 10. So in this case, this is okay. We would say, yes, this is a function because each input has only one output. And you might say, well, what about the 10? The input of a 5 only has one output. The input of a 12 only has one output. So even though there are two sharing the same output, that's okay. Looking at the second one. So if I look at this, -2 comes out as a 4. -1 comes out as a 3. 0 comes out as a 5. 0 comes out as a 6. 1 comes out as a 6. And 2 comes out as a 7. So hopefully you're already caught on here where a mistake or problem is. 0 as an input cannot be two answers. So 0 cannot go in and come out as a 5, and also go in and come out as a 6. So in this case, this is not a function. It is still a relation. It is still ordered pairs. I can still graph this if I wanted to, but it would not be classified as a function. So every input has to have one output. So the last one here we want to look at, we have a mapping diagram representing the prices of a one-way subway ticket to different zones of a city. So if we just look at this, we're seeing that in zone 0, the price is $2. In zone 1, it's now $3.50. Zone 2, it's $5. Zone 3, it's $6.50. So the first question we have is the price of the ticket a function of the zone number? And basically what that means is every input of the zone numbers is there only one output. So yes, this is definitely a function of the zone number. Describe the relationship between the price. Now, sometimes we will start to see that we can see slopes and we can see straight lines and we can see definite relationships. So you always want to be on the lookout for our numbers. So if you think about this one for a second, notice what's happening over here on the inputs. These are all increasing by 1. So there's definitely an increase of 1s, which makes me now wonder what's happening on the other side. Looking at the other side, I see plus $1.50 for each of the zones. So that tells me something right there. So basically, to put that into words, describe the relationship between the price and the zone number. So for each zone, there's an additional $1.50. And that would be a way to describe the relationship that we're seeing between the zone and the price as I go further into the city or out of the city, depending on which way the train is headed. So that's the basic starting point of this chapter, relations versus functions. Relations are any time we can put together inputs with outputs. Most commonly we see them as ordered pairs. We can see them in a table form of X and Y tables. We can see them on graphs of points that are plotted from ordered pairs of X's and Y's. Functions, which we'll talk about more as this chapter goes on, are when we have every input or every X value only has one Y value that it comes out as. So if you have any questions, feel free to ask, and when I see you in class this week.